Welcome to another tutorial in Ansys Workbench. In this tutorial, we are going to compute the hoop, radial, and longitudinal stresses that develop in a cylindrical pressure vessel with rounded end caps. The pressure vessel is 4 meters long, and the end caps have an outside radius of 1 meter. The wall thickness of the pressure vessel is 0.2 meters. There is an internal pressure of 1 megapascal in the tank. We will apply model reduction principles in this tutorial to reduce the size of the model. As part of this model reduction, we will introduce the concept of symmetric boundary conditions. I hope you enjoy the tutorial. After opening SpaceClaim, the first thing I will do is change the units from millimeters to meters. So I'll click on File, come down and click SpaceClaim Options, click on Units, and for this document I'll change the length to meters. Then click OK. Then I will right click and left click select new sketch plane, click on the XY plane, click Plan View. I'll now create my end caps. So to do that I will come and use the Sweep Arc tool. So I'll click on Sweep Arc. To do this, you click the center of the arc, then you expand it out to the radius, and I want a 1 meter radius, so I'll just type in 1, enter, and then you swing the arc the distance you want and type in the angle, and I'll type in 90, enter. I'll now come back and click the center point again, expand this out to 0.8 meters, and swing the arc 90 degrees again. You can see that I messed up here and I didn't quite get the 0 to begin with, so I will do an undo and come back and click the center point, scroll down to staying on the center line, scroll down to the distance and enter 0.8, enter, scroll around until I hit the radius and the angle that I want and type in 90, enter. I can now click on escape and I can come in and add straight lines here. So I will come to the line tool, click on line tool, highlight the dot, the sphere, and create that line, and then come up and create that line. I'm now going to copy this and move it to the top, so I can come up and do a select and do a box select, and now I can click on move and highlighting the vertical arrow and holding down the control, I will do a copy and I will move this up, and I'll move it up 2 meters, so 2, enter. And now I can rotate this, so I will not hold the control because I don't want to do another copy. I'll highlight the rotation arrow and I'll swing this 90 degrees, enter. I can now come up to the line tool and connect this geometry by clicking on this point and then left click this point, escape, and then left click on this point, and I now can click escape again, and I have a draft of the cross section. So I can now come up to the pool tool and I'll click on these 3 areas. So I'll click left click, control left click, and control left click, and now I come over to the swing about an arc tool, and so the revolve tool, I click on that, and now the next thing I do is click the axis that I want to revolve about. So I come over to the y-axis until it's highlighted, click on it, and then I come over to my body and I can control middle mouse button this and move it to the center, and then control or middle mouse button and swing it so I can see my arc a little bit, and I can just grab and click this and I can type in 90 degrees, and I now have a 90 degree section of the cylinder, and that's what I want to model and use as my model. So I can go ahead and save this and then bring it into. After opening Mechanical, I can see my structure in the project window. It looks like it has been brought in correctly. I can come over to my project tree, click on Geometry. I can see that I have one solid. I can click on that solid and see the details of it. For example, I can see the material assignment is structural steel. I can then minimize this window and come down to Mesh. If I click on Mesh and click Generate, it will generate a tetrahedral based default mesh. I can see that that mesh isn't too bad, but we want to introduce the idea of a swept mesh in this tutorial. So I'm going to come up here to Mesh, right click, and if I want to clear this mesh, I can come down to Clear Generated Data and click Yes. Then I can come back to Mesh, right click again, and Insert Method, or I can just come up to the top toolbox and click on Method. Now I can click on this body and click here on No Selection, click Apply, and I have the one body that I will be looking at. I'm going to change the method here from automatic to swept, so I click on the automatic box, click the drop down, and come to sweep. Now these are the details of my swept mesh. What I want to look at here is the source and target selection. So one of these edges along here will be the source and the other one will be the target. And the idea is that the elements start at the source and propagate through around to the target. So I will come here and change this from automatic to manual source and target. And now it's requesting that I enter in the source and target. So I will rotate my structure, click on the surface select tool, click on this edge, click apply. Then I'll come and click on this edge, rotate my structure with my middle mouse button, click on this edge and click on the target, no selection, click apply. And I now have my source and target selected, and I can come up and generate the mesh, or I'm going to continue on with defining some parameters of this mesh. I want to use, instead of a quad tri, which means quadrilateral and triangular elements, I want to use all quads. And the number of divisions indicates the number of elements that will be used around this circumferential direction. So I will change the number of divisions from default to 10. And I'll have 10 divisions coming around the circumferential direction. I can now come up to Generate, and it generates that mesh. It says it's ready. My elements don't appear, but if I come to Mesh and click on Mesh, I can see my elements, and I can see that I have a much nicer looking mesh. I want to refine this a little bit more, so I come to Mesh, and then I click on Resolution, and right now it's set at 2. I can increase this resolution to 5 and click Update. When I click on Update, I need to make sure that I hit the Enter, and then I can see that my mesh is turned pink, and that means that I have an obsolete mesh or update that needs to be taken care of. So I'll click on Update, and then I can see my new mesh, and the mesh is a much better result. I will go ahead and use this mesh. To introduce the symmetry into the model, you come up to Model and right click, Insert, and scroll down to Symmetry. And now we have to identify the specific symmetric boundaries. And so I'll right click on Symmetry, Insert Symmetric Region, and now I'll come over and I'll click on the Surface Select tool, and I'll click on that surface. Then I'll click Apply. I will go ahead and use a symmetric type, and you need to identify the symmetry normal. So to do that, you need to come up and make sure that you get the normal axis. And so the normal to this would be the x-axis, which is the default. I now need to come to symmetry again and identify the other symmetric region. So click on symmetry region, and now I'll click this face, click apply, and now my symmetry, the normal to my symmetric axis is the Z axis. So I need to come down here and change this to Z axis. I now come to apply my boundary conditions. So I'll come to static structural and I'll apply a displacement boundary condition. And the only thing I need to do here is keep the system from going off into infinity in any of the directions. So I only need to fix the boundary at one vertex. So I'll go to my vertex select and I'll click this end vertex, click apply, and I'll simply fix the displacement in all three directions at that one point. Now I can apply my pressure. So I'll come to pressure and click that face, control click the other two internal faces, click apply. I have three faces. I'll click my pressure and I'll enter in 1,000 pascals for my pressure. I now have all my static structural that I need. I'm ready to go to solution, and we know that in axisymmetric problems the principal stresses are the R, theta, and Z direction stresses. So I'll come up to stress and I'll enter equivalent von Mises. Then I'll do the maximum principal, which will be the hoop stress or the sigma theta stress. Then I'll look at the middle principal and the minimum principal stresses. I'll come to deformation and look at the total deformation as well. I'm now ready to solve the model. After a solution has been obtained, I can look at the results. There's my equivalent stress, which should be predominantly the sigma theta stress, and it looks like it should, where it's maximum on the inside surface and then decays as it propagates outward. That should be pretty much the same as my maximum principal stress. Then I go to my minimum principal stress, and this appears to be my sigma longitudinal stress. And then I can look at my minimum principal stress. This is my radial principal stress, because I can see that this minus 1014 is very close to the 1000 pressure that I put in there, and we know that that's the boundary condition that should be met. I can then look at the total deformation, and I can see that my deformation is on the order very small, and which should make sense for the very small pressure that I put inside of this tank. I can watch this stress propagate as if I can click on maximum principal stress and come down to animation and click play. I can see how that principal stress propagates through as the load is increased. I can also do this for the other stresses and for the deflections. I hope this tutorial has helped you see how to use symmetric boundary conditions and understand better the principal stresses in cylindrical